morning, good afternoon, good evening, everyone. Thank you for joining us today. I am Jas, one of the co-founder of True Gradient. We're very excited about this workshop, one of the first which we are doing, and hopefully we'll be doing more such workshops. And I'm, joined here with Connor, who is graciously accepted to come here and share his experience. We call him a 10x analyst from Franklin Sports. Been working with us for close to a year now. And we have Ankur, who's also one of the co-founder and CEO of True Gradient. So before we get into what we're going to cover today, Connor, maybe quick introduction about yourself, and then Ankur, and then we'll get rolling.
Yeah, thanks, Shaz. My name is Connor. I am located in Boston, Massachusetts, working at Franklin Sports as an e-commerce forecasting analyst. Been at Franklin for about 4 years. I studied applied mathematics and statistics in college, and I love this stuff.
Excellent. Ankur?
Thanks, Jasneet. Hey, this is Ankur, co-founder of True Gradient. Welcome everybody to the session today. My background is in machine learning, and we are looking forward to talk about the True Gradient, machine learning, and planner in detail.
Excellent. Thanks, Ankur. So 10x Planner Workshop, right? The word 10x has a background, a reason here. 10x, we've entered a very fascinating era of AI, where AI can be a force multiplier. That's why we came up with this term 10x, meaning, especially for lean teams in mid-market, which is where our main focus is, it gives the ability to planners, analysts, merchants to become 10x, right, by using modern tools. So today what we're going to cover is three parts. There are three parts of this webinar. The first is basics. We always talk about data is messy, data is not clean, fragmented systems. So how do we solve that problem first, bringing the data together, cleansing the data, right? So we're going to use some visuals for some context, and then we will go to the platform. We'll show you, how it looks like in the platform, and then we'll have Connor share his experience, how he has been using the platform, his learnings, and we'll also have Ankur also provide some commentary. So so that's the first part, right? Data, and the second section would be about neural net or deep learning, and why deep learning or nonlinear models are a better fit than legacy models, especially for volatile model, and what does it mean really, right? So we'll try to explain it in a simple manner, and we'll also again share some visuals. We'll especially talk about reinforcement learning, which is where actually Connor had been one of our early adopters, and he's been an early adopter of not only reinforcement learning but also TG agents, agentic AI. So that will be a very interesting section, which is section 2, where we'll go into and discuss neural net and agentic capabilities. And the third portion is all this doesn't mean anything if you're not able to understand the why behind the forecast. It's very important. We've been in the industry for quite some time, and one of the questions we always used to get is, okay, how do I trust this number? So that's where explainability comes in. That's where able to understand what are the building blocks of forecast, factor contribution. So we'll explain that, and again with agentic capabilities, explainability is becoming much better. That will be the third section. So with this context, let me talk about the first section, which is the data, right? So, so data, basics again, right? As you can see in this visual, data is typically all over, right? It can be in Excel, Google Sheets, ERPs, data lake, warehouse management system. And the first step is to be able to bring that data and clean that data and in a timely manner, right? The main thing is how fast we can crush those typical timelines, which would take months into weeks to bring the data into the platform. So let me show you real quick. This is the side of landing page where we have agent which can interact with the business planner, merchant, or analyst. But we're talking about data here. So typically, we are able to bring the data from several types of source systems. So what you see here is an ability to ingest, integrate in a API integration, REST API integration manner with the usual suspects. So typically SAP, or Azure Data Lake, GCP, Microsoft, Shopify, Snowflake, or even Databricks, which is where we bring the data in. And if it is existing in Google Sheets, we're able to quickly bring the data in and bring that data into our platform. But this is all raw data pulls, right? So once we bring the raw data in, the second part is to actually to be able to uh, create an underlying data model, to be able to bring data, sales, historical sales data, let's say, historical inventory data. How do we come and build an underlying data model in an efficient manner? That is key, right? Because traditionally in legacy system, just creating the underlying data model, which is also called data engineering, would take a lot of time. So this is where capability of a no-code, low-code agentic platform comes into play, where we are able to stitch the underlying data model, in an efficient and a faster manner. So, what you see here is we got, let's say the historical sales data. The platform is able to bring in the data from the source system. There is some manual tagging which we will do, or a human can do, and there is also automatic tagging which the machine does. So things like, for example, granularity, formats, etc., labeling the data to be able to understand what the data means. So sales, inventory, etc., all several types of data, item master. And what is key where I'm going to stop is that the ERD entity relationship diagram on the underlying data model sort of is created by joining the, let's say, the key data tables. In this case, I'm showing sales and inventory data. We've joined the data, and when we join the data, the underlying data model is ready. So that is what, once that is ready, then you have the base to run experiments, you have the base to run AI pipelines, and able to generate out of the box planning workbench and reports in a matter of hours, actually, or validation takes weeks, a week or so. But once the foundation is done, the next step is running the models. So the second step is the cleaning portion, right? So now I'm gonna lean on you, Connor, right? I've brought up this planner coding panel over here. So there are automated algorithms, obviously, in our platform, or traditionally also in legacy, where you can go and detect and fix outliers. But on top of that, there is a merit of what I call surgical operations on data, on historical data, right? What I call planner-led layer of logic, because planners or analysts can apply contextual rules that can significantly improve data quality, right? So can you explain how it was in practice for you, and what are those situations where planner coding or planner insights are important? And I'm going to bring up this screen over here and just show you guys that several types of operations which are available, where a planner can come in on top of automation and go and layer in his or her insights to fix the historical data. We always say garbage in, garbage out. So this is a very powerful capability. Connor, why don't you please shed more light on it?
So what makes planner coding so useful is right now, post the historical data, we have hindsight. We understand why things happened in the past, whether it was a stock out, whether there was a channel shift, any type of demand that was not organic, such as we could have company could have run out of inventory, not been able to supply the product. Going forward, the model might read there was a lull. There was an empty period of several months where they weren't buying. That is clearly not a trend that is going to go forward. And if we model off of that, we are just going to continuously run into these same issues. But with hindsight, we can go back and adjust that and make that surgical change that Jazz was talking about.
Excellent, excellent. Thanks, Connor. So that is the idea of ensuring the history is not corrupted due to artificial issues. I always give this example of out of stock situation, which is a supply constraint, which is not natural, and we should ensure that those kind of situations are treated, and on top of what the automation can do, right? So going back to what we just covered, just a quick recap. Able to first bring the data in, right, from different sources, right, so that you have one consistent source of truth, and doing it fairly quickly in a no-code, low-code manner. Then that's the underlying data model. So planning use cases ready in weeks rather than quarters, and then able to clean, standardize, impute the information through automated algorithms as well as planner coding, which Connor explained. So that's the first part. So decision-ready data is the foundation and the first part of this webinar, which is what we'll try to cover. So the second portion is also very interesting. We always get this question asked, right? We are a neural net reinforcement learning first company, right? And and again, what does neural network mean, and why it is more effective and capable than traditional models, especially when it comes to mid-market as well. Again, because super volatile due to promotion, price, changes, channel noise, supply shocks, etc. And Ankur, I'm going to go into the platform, and then I would love you to talk a little bit about neural net over here and what does it mean.
Absolutely. No, thanks, Jasneet. So, first of all, what does really neural network mean over here? And why are we able to? Neural network has been a concept which has been there since 40 years, 50 years, 60 years now. 2000 after 2010, compute became accessible, and hence we were able to run these models. Really, it was accessible to each one of us over here. But theoretically, it has been since ages, and people have been using it thoroughly in doing the mathematical computations by themselves. Actually, the reason behind neural network inception was, as the globalization happened, as so many brands came in perspective, I'm talking in the sense of retail, CPG, capturing non-linear behavior became very, very important. That's exactly what neural network architectures are able to do. To be able to capture the competition, huge competition, to be able to understand nuances of the simultaneous nuances of, let's say, price changes happening during an event time. That is also something, let's say a storm is coming. So there are so many instances which happens. While I was working at Walmart, there were times wherein we used to figure out what led to this drop in sales for this store. And it was really impossible to do that if we were linearly thinking about it. And that's where the inception of neural network came from the retail perspective. Hey, can we build some models which can by itself identify these kinds of trends and help us identify the reasoning behind that? So that was the first part that I would like to state. Like, neural network is nothing but capturing non-linear instances for there. Going beyond that, in today's world, does really saying that, hey, 100 units is what I will be selling in March cuts for that product? It's very hard, because when you talk about a let's say a company which is at the range of 100 million, 200 million, 50 million, 10 million, the market is changing significantly. So you need to have a range over there. So that's where neural network kind of architecture can help you not only identify the point forecast, point or a point solution, but also give you a range of solutions. And that's where planner kicks in, because if there is a planner who is looking at not just one number but also able to see the conservative value, how conservative can it be and how aggressive can it be, it gives a perspective, right, for a particular point in time. And that's that's what Jasneet is showing over here. So green line that you see is the point forecast that has been generated, and there is a prediction interval in P10, P20, all of these probabilistic forecast is being used over here. And at this point of time, Connor, why don't you pitch in, like, and Connor has been a user of this, like, as a massive user of this. I have learned a lot from him as well while he uses this, because he incorporates a lot of business context into perspective, especially for a lot of different types of items. So would love to hear, Connor, your point of view as well on the same place.
Yeah, with nonlinear models, there's so much that we could not, we have all this data, we could not capture it and like actually get meaningful answers through linear models. Being able to look at, different confidence levels and understanding the risk at each level really kind of helps bring discussions together. As opposed to, just having one number and then basing everything around that one deterministic forecast that a linear model would output.
Absolutely. Thanks, Connor, for that. And then that brings me to the conversation around the reinforcement learning. What reinforcement learning is capable of doing is, as we know, the concept is very simple for RL agents or reinforcement learning agents as well. You provide different types of possible actions. So in this case, the possible actions are the different types of forecasts which are being generated. The probabilistic forecast, the offset forecast, your any time series forecast, econometric forecast, all of these types of forecasts that are being generated over there. And we do create a reward function on the system, the reward function which can help optimize my forecast for the next time step or next few time steps to be more accurate. So just to give you an example where this beautifully helps is, and again, a lot of our customers utilizes this fact, is, let's say a particular item is dying, right, and it's dying, was aggressively being sold a couple of months ago, and it's just started dying in the latest time frame. What that would mean is, can the model react to that dying situation and do prediction accordingly? So that's where reinforcement learning kicks in certain times. Like, hey, I don't want to be at P50 or P40 level, but I want to go to the P10 level because this item seems to be dying, at least in the near term future. So we create the reward functions based on accuracy levels of last few consecutive points. And this is also something which we have simulated from the planner perspective. You can also do the same activity on the platform which a planner does. So if we go to the demand planning page as an example, and if we go to the table down there, right. So in this, as we can see, while we are taking a decision for, let's say, August 2025, so we look at the locked forecast, what was locked, let's say lag 3, lag 4 time frame, whichever time frame is relevant. We have the understanding about YOY percent change, how much percentage did change from last year to this year. And if we go in the backward time frame, maybe July and June, so we have a visibility to accuracy and bias. So that gives us how accurate have we been predicting, let's say for cookies, for let's say Montreal DC over here, or San Antonio DC, for that particular purpose, like what has been the accuracy for that, and have we been over forecasting or under forecasting. So this gives us a confidence to be able to accept the machine learning forecast, or say that, hey, seems like the model has been off a lot in the last 3 months. We have been under forecasting this every time. Maybe there is a need to change this particular forecast over there. So these kinds of inputs are being learned by the reinforcement learning, and by itself it can react to such situations, and yes, over a period of time start taking such judgments as well in the nature. So that's where the non-linearity comes. Yes, just need to over to you.
That was great. I mean, Connor, also on this reinforcement learning screen, again, you've been really an early adopter of RL as well, right? So if you could also share your experience, how you have used it, that will be great for the audience.
Yeah, it's great because reinforcement learning, like Ankur mentioned, it's scoring these suggestions that we are giving it as we're enriching the forecast. So, a lot of times we go into meetings trying to come to a conclusion of a number and trying to take suggestions all into account. And then 3 months will go by and we do not remember those suggestions that we put into place, why they were wrong, did they help? So with this, we're allowed to feed the model this information, this thought process, this business logic that it might not have that there might not just be physical data for.
Yeah.
And as it sees these business things that we are seeing in each specific company, it slowly will tailor and it will slowly adjust to recognize these types of patterns.
Excellent. No, thanks for sharing that. And then, whatever we spoke in the section, if I have to do a quick recap, in let's say top three takeaways. First thing, as Ankur and Connor were discussing, that neural nets can learn from complex relationship, right? So ability to, which is where the traditional models are not able to detect hidden demand patterns. So we live in a non-linear world. That is, first of all, a reality and the main thing here, right? And then, as we know, all, brands and retailers generate massive amount of data, right? That's where, again, neural net really shine across channels, queues, time periods. So neural nets can scale, right, especially for a fast-growing brand or a retailer, hundreds of demand drivers, so enabling better prediction. And another very important point, also very relevant in this situation, Connor, as you would agree, Franklin Sports, we always used to see a lot of things used to change dramatically, especially when tariffs were introduced. We saw how demand literally, changed for different categories and subcategories, and that's where again RL and neural nets are able to adapt quickly. So that's how sort of I will sum this up. That's the second section. We're done with the second section now. The final section of the webinar is this is also a big topic, right? The why behind the forecast. So we if we are not able to show why the number is suggested, again adoption will not happen and value realization will not happen. So the idea of making it as transparent as possible is what we call explainability. So let's go back again into the platform, and I'm gonna bring up a screen and talk about what we call factor contribution as well as agentic capability. So what you see here is we have this ability, again in this is the sales history and this is the forecast in green. What we have come up is still in beta version, but we've come up is called factor contribution, where you can anchor on particular data point in the future and able to understand, right, what are the different drivers of demand, if you will, like holiday, offset, and how much it has contributed. What is positively contributing, what is negatively contributed, so that you can understand your growth drivers and double down on the growth drivers rather than the ones which are. This is also sort of ability to understand, underlying feature engineering. There are several features which go into a machine learning model. What we do here, expose the most significant ones for you to understand what is driving your business, if that makes sense, right? And Ankur, I would have you provide more color commentary over here, and then we can also go to Connor to share his experience, not only on the factor contribution, but the other thing I want to highlight is, we also have inbuilt agent, which where you can ask questions like, what are the key drivers behind my forecast changes? That's in itself is a question which explains the drivers. So agent plus factor contribution is a powerful way to kind of sort of explain the outcome of the model, right? I'll go to you, Ankur, first, and then and then Connor, for you to also share your experience.
Absolutely. And in my last 12 years of forecasting experience, every time when I've been doing forecasting independently as a data scientist or working along with the planner, the question always has come, how can I explain this forecast? Why are we saying this forecast to be a 2,000 units and not 1,000 unit, right, over there? What is contributing to this over there? So this has been a topic of discussion, and really something which a lot of research, like science research, has been done over this. And that's where we felt that, hey, if we are providing something in a modern tech, it's very important not only for ourselves but also for planners who are trying to make sense of that data, right? So yes, one way to accept a forecast is looking at the historical accuracies. That's true. But then the nature of forecast is very, very, like, it changes significantly. It can die, it can go up aggressively. So it's important to understand what is contributing to that factor. So as this need showed, as a factor contribution, we are able to dissect and bisect the factors out over there, that what percentage is holiday contributing, if there are interactions of if at the same point of time holiday is there, price change is there, and event is there. So the non-linearity is able to, I mean, it won't be 100% accurate, but yes, it will try to deduce that kind of factor as well, to be able to establish like what contributed to that forecast. So that is one part of it. And once we make these kinds of richness, we bring these kinds of richness to the data, that's where the AI agents kicks in. That means the AI agent really knows, when you ask a question from an AI agent, it can backtrace and provide you very pinpointed answers around the question. So it just becomes like a chat GPT or perplexity of the world, where you're just going and asking a question and you're getting a deterministic answer out there, which can help you take decisions, a planner decision, that should I accept this forecast, or should I
Yeah.
say that, hey, I want to make some adjustments. Connor, would love to take your take as well on this.
Yeah, and we talked about linear models earlier and just how difficult it is for them to, take in all this data. Even afterwards, there's so many things that are going into this, and every single case, even month by month, is different. There's so much seasonality. We talk about all the pricing and stuff like that goes on. Things change so much. And like you also mentioned, Ankur, people just want the explainability of that value, and having that to understand, like, hey, this is not only what's driving that value, but this is what could change that value. Right. And being able to, making sure we're feeding the agent those questions. It's learning based upon, how it's constantly seeing, pricing, promotions driving huge forecasts and causing huge misses, and it's just creating a good feedback loop, and it creates clear transparency, like across the company in all levels.
Absolutely. I always say that, adoption, at the end of the day, if the bottom line is, if things are not explainable, people are not able to validate things in a simple manner, it will not at least culminate to the value which the technology can deliver. So the technology is there, the more it becomes explainable, the more it becomes easier to interpret, the better it is for the planners, merchants, and analysts out there. So with that, let me also summarize what we heard about explainable AI for demand planning. So we spoke about why it is important. We have spoken about it. Obviously, it builds trust, right? It helps in adoption. Driver-based forecasting means we are breaking down demand forecast into its drivers, right? We spoke about price, promotion, seasonality, holidays, etc. So you're able to see exactly the components of demand, if you will. And factor contribution analysis together with agents are able to understand again what are the variables that is impacting, and what is kind of help you identify what is driving growth or decline, right? So that is sort of the three takeaways here. And almost reaching the end of the webinar today, but I have two more questions, and we also want to take questions from the audience, but I have two more questions, one for Ankur and one for Connor as well. And Ankur, I wanted to ask you that what does People are asking us,
Yeah.
right, what does really 10x planner, 10x analyst, 10x merchant mean in the era of AI?
Absolutely, Jasneet. And that's a great question, and we have been pondering over this since a while now. This is all emerging from obviously our past experiences as well. I mean, a very small anecdote of my Walmart experience comes like I used to work for a category where we used to have like six planners working on that category. It was like a 3.5 bill category that we used to work on. uh, I mean, the planners used to spend 15 hours, 16 hours every day during a point of time when,
Mm.
let's say, a markdown is happening, especially when you are trying to
Mm.
like match your markdowns with your sell through, trying to optimize your sell through, trying to also
Yeah.
figure out the forecast at that point of time. So the concept was, can we build a technology which can really get this time 1/10? I mean, in a very
Mm.
simple language, if I'm doing a planning activity, right? If I'm planning demand, if I'm planning supply, if I'm planning a promotion, if I used to take 10 hours to build a solution, I should bring
One.
it down to 1 to 2
1 hour.
hours.
Yeah, yeah.
That's 1
And
hour,
then they
right?
are able to work on higher value added work, right? And
Exactly,
that means we're
right.
growing the pie, we're
Because
growing the business,
they know
and
the
yeah, you're reducing the firefighting in the business and work on things that matter, right? So
absolutely.
brilliant. Yeah, very good example. And Connor, I have a question for you as well. You, like in my opinion, is you know great example of a modern 10x analyst. And if you have to share, what is that one capability that a 10x planner or analyst should kind of think of in this modern era of AI? What will that be?
Flexibility. Flexibility and breaking out of the mold of what traditional forecasting has looked like.
Mm.
Specifically for me in the e-commerce space, it's moving so fast. If you're not adapting,
Mm.
you will be left behind.
Mm.
Um, and with that flexibility, giving you the opportunity to focus on what's important. Ankur,
Yeah,
you talked about those 15, 16 hours, maybe only a subset deserve that attention to detail.
yeah, exactly.
Being able to automate, being able to get those small fries out of the way and then really focus on the big drivers. That I think is huge.
Perfect. Absolutely. Very well put. All right. We are at the end of the webinar here. Session is open right now. If anybody has any questions, feedback, etc., you can put it in the chat window. We also, obviously, our coordinates. Okay, so that's the question coming. Gabby, for Connor, what is the biggest challenge you face in using AI to improve forecasting?
I think the biggest challenge is taking too much data in almost sometimes. Sometimes taking in too much data, but not taking in the right data and just thinking we need everything. We need to bring everything in. And I feel like that really messes the waters and it really creates like, you're, you really get set in a certain way, I feel like, in that sense. And you're not going to get the most accurate output.
So, can I say this, Connor? What you're trying to also say is that sometimes we just introduce noise in the system, right? In the name of data, more data, and there is no statistical significance of certain data, and we try to bring it in, and it becomes more messy. And the first part of the engagement AI process is to be able to understand also what is noisy data and what is good data, and only let that sort of go into the modeling layer, right? So that is that a good way of also kind of rephrasing what you just said?
Yeah. Yep.
Okay, cool, cool, perfect. Thanks, Gabby, for that question. That's a great question. I think that also is a relevant question for rest of the audience over here. And I think there is another question: does True Gradient have plans to incorporate instant forecast competitor promotions? Okay. Yes, Sanjay. We already have that feature. We have. I think I did show in the beginning. If not, but we definitely are able to include macros, external factors. Again, the key is that whether that is statistically and what use case we are solving. If we are solving long range planning, yes, then macros are important. But if you're doing sensing, maybe weather would be important for example baked goods. So it depends the relevance, right? Okay, then another question come from Nick here for Connor. In using AI as it relates to forecasting, which variables are critical for optimizing projections and building predictive models?
I think I think pricing. I think the pricing variable is probably right now the most important one that we're seeing on from a retail standpoint. So many competitors, so much fluctuation and volatility. Everybody's trying to get one leg up, try to make a product better, cheaper. So I think pricing in a competitive market, it really is one of the most important variables to keep track of.
Great answer. I think can't deny that, right? Can be. That's absolutely right. Especially for e-commerce retail context, right? Just to also qualify that, price is one of the biggest. Great question, Nick. Thank you. Hope we also answered Sanjay your question too, right? And so yeah. Any other question from anyone over here? Okay, let's give. Okay, one more question from Connor. Okay, from Zach. Sorry, for Connor, can you speak to the measurable outcomes that we have improved at Franklin since? Okay, that's a great question. I think that's the point where Connor we can talk about the forecast accuracy if you would like to shed light on that, right?
Yeah, we've seen our forecast accuracy has improved tremendously since working with True Gradient, especially as we've been able to really take into consideration previous month trends at a different level as opposed to looking just year over year, looking at different rolling periods and everything. And that alone has caused massive spikes in accuracy, along with it opened us up to a lot of holes that we had in our business, a lot of areas where we weren't realizing, oh, this is actually something that we need to focus on. We've worked with True Gradient, we've enriched the forecast, and that's just continued to improve our accuracy to this day.
Zach, does that answer your question, Zach? Visibility, how it has flowed down to the P&L, improved buys. Okay, so Zach's follow-up question is, do you have visibility to how that has flowed down to the P&L, improved buys, better receipt flows, improved margins, etc.?
I do not.
Yeah, so the answer is not yet, Zach.
I think there is a question from Suhail as well. How does the model? Yeah. How does the model handle external factors that aren't in the data? Say, for example, competitors' sudden price drop or social media trend without a planner manually overwriting it. That's a great question, Suhail. And typically in True Gradient, what we do is, from the competitor standpoint, we have to curate those data sets, right? So fortunately now we are living in the age of agents over here. So we do, let's say we are forecasting a particular item. So our AI agents are able to get some directional pricing or promotions that are happening. It will not be 100% accurate, but it will be like 60 to 70% accurate, which will flow as a data model into the system and give some directions around that. And then on the social media part, yes, we are connected to Instagram, like if we're like Facebook, Instagram, like those kinds of TikTok, like these kinds of marketing spends, Google marketing spends, if those kinds of things are happening, then yes, for every customer we do past marketing spends and so the social media trend into the system to be able to learn that and project that in the future as well over here. But yes, there are some manual interventions that planner needs to do certain times if it is unreasonably controlled ones, not controlled ones situations. Does that answer your question, Suhail?
So, did we answer your question? Uh, any other question from anyone? I see Stephanie is on the call too. If you have any questions, good to see you in the workshop today. Uh, Jamie, Jerry, if you have any question. Okay, Lindsay. Within other companies you have worked with when starting to implement predictive models, how do you help other departments within the company to trust the models? How do you help other departments within the company to trust the models? It's a very good question. Uh, so I think Lindsay, let me take a stab at that, Ankur, and then
Yeah.
you can bring your perspective as in. I think the key is about when we are doing demand forecasting, the process of consensus planning includes inputs actually from different departments. So let's talk about the process and then talk about how do we win trust of other departments, right? So the short answer is obviously the performance, right? The short answer is things are transparent in the system. You have a sales history coming in, actuals coming in, forecast coming in, and you can measure accuracy, bias, sales weighted map, and it becomes clear that adoption will lead to improvement in downstream processes. And Zach's question to downstream processes in supply planning, etc., etc. But the way we should be doing this is that we have a version of truth. What the way we do it, there is a version of truth recorded in the system, which is what the AI forecast says, demand planning forecast says, what is sales perspective, or what is maybe marketing perspective, and all those numbers are recorded. And when the actuals comes in, you can do performance hindsight analysis and see, okay, this is where was the right behavior, business took the right decision to enrich the numbers. This is where it does not. And if you look at the overall trend, there's a certain segment of data where machine learning is always coming out with a better answer, right? And so it goes back to basically able to see the predictions and actuals coming in and doing those hindsight analysis, and then sort of getting into that loop where the trust is established. If it is all about, if it is, in when the consensus planning is itself happening, ensuring adoption over there, that's where factor contribution or agentic capabilities are able to help to ensure the numbers are explained in a manner that so that business can understand and adopt. So that's how sort of I will answer. Hindsight analysis and this explainability capabilities are two, let's say, levers for us to help kind of bring more people on board to ensure that we have a tight SNOP process, or driven kind of superpowered by AI or driven by AI insights. Lindsay, did that help? Long story, but I wanted to give you full context. Perfect. Excellent. Uh, if there is any other questions, feel free to shoot. Obviously, you have our coordinates. Okay, great. The use case neural net is well suited to. Okay, I'm going to read it out. You have mentioned that use of neural net is well suited to highly volatile. Are neural nets equally suited to projected demand and cannibalization for new product? Absolutely. And market historic? Absolutely. A short answer is, in fact, new product forecasting is one of the strongest area for neural net. Because why don't Ankur, I give this to you? This is your favorite topic, right?
Yeah, for sure. Yeah, I mean, in 2000, again, I always refer to the time. So, like 6, 7 years back, we had a paper in which we said that, hey, there are some. It was a fashion retailer, it's a massive fashion retailer in Southeast Asia part of the world, and I was a part of that particular engagement as well, while in my previous company. And then we said that, hey, how do we forecast this new product? There's a neural network setup which is coming. Can we do some kind of benchmarking over that? We did neural network setup. So what that means is we sort of created those product masters, MRPs, and said that, hey, let's cross learn from one another. There are certain things like cannibalization activity, substitution, substitutability, halo, all of these things happening while you are trying to train such models. And when you incorporate a new product, the neural nets are really capable to identify the like behavior items in terms of trend, in terms while the other item had started, in terms of seasonality, in terms of MRP, in terms of any other attribute which you would like your new product to learn from, and it flourishes. So the end result, I can share that paper as well with you, Zach. It's a beautiful study. You can do the study of that paper. But the end result of that was, compared to any other model, traditional model, neural network flourished, and we were able to gain some good amount of accuracy benefits by incorporating the cross learning phenomena, by making our product master richer and richer, and by being able to identify those substitutability and halo items from the existing to new product mapping. So I think this is how the theoretical world has been progressing over a period of time, and today new product forecasting using neural network has become a reality.
Got it, Zach. I mean, yes, we will share the paper. Yes, basic attribute-based forecasting is very, very traditional, and neural net is actually a very, 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 suitable technology for those kind of use cases as well. Especially new product forecasting is a really hard problem to solve again. So, okay, great question, Zach. Thank you for asking all that. I'm sure those are also very helpful for other people on the call here. We have this session also recorded, so we're going to share the recording of the session so that this knowledge is retained. And really appreciate here, Connor, your time and your insights which you have shared today. And like I said, if there are any follow-up questions, feel free to reach out to us, and we'll be releasing this recording in a week or so. And thank you so much, everyone. Thanks, Ankur, for sharing those brilliant insights, and thanks, Connor, again.
Thank you both for having me.
Thanks, Connor. Thanks, Jasneet.
Thank you, everyone. Bye bye.
Thank you, guys. Thank you, everybody.